There, this is Teacher Raya. Thank you for visiting. We are going to do question 3 from 2015 NECTA Form 4 Math paper. So let's start. So for question 3a, we are asked to find the solution set of the inequality x over 3 take away 1 greater or equal to 2 take away x over 2. So I'm just going to write that here. X over 3 take away 1 greater or equal to 2 take away x over 2. And it says solution set. Do you know why that is? Well, because it's an inequality. There is more than one answer. If we had just an equal sign, then we'll just have one answer. So let's find the solution set then. How would you deal with this? We've got x on both sides. So the best way I recommend you do is get rid of the smaller x. I've got x over 3 on the left hand side, and I've got negative x over 2 on the other side. So which one is the smaller one? Obviously the negative one is a smaller one. This means we're going to add, do the opposite of subtract to get rid of this lot here. So we're going to add x over 2 both sides because we need to balance it. So now I have x over 3 plus x over 2 take away 1 greater or equal to 2. What will happen to this one? Well, this will now become 0 because that is what we wanted. Negative x over 2 plus x over 2 is 0. Okay, so now I'm going to do two things at the same time. I've got two fractions here and I've got take away 1. I'm going to add 1 both sides, and I'm going to add these two fractions. They need to have the same denominator before we can add them. So the common multiple is 6. This number needs to be multiplied by 2. This number needs to be multiplied by 3. But you need to remember to balance it. So I'm going to have 2x over 6 plus 3x over 6. And now I'm adding 1 to get rid of that negative 1. So I'm going to have greater or equal to 3. Okay, so 2x plus 3s, they are like terms. That means I can add them. So that's going to give me 5x over 6 greater or equal to 3. Now, how do I deal with this 6 over here? It's been divided at the moment, and I need to get rid of it. What do we need to do? Well, you need to do the opposite. The opposite of division is multiplying. Okay, so we're going to multiply in order to get rid of this. But what else do we need to do? We need to balance it. So we need to do it on this side as well. So this goes and that goes. Then you have 5x greater or equal to 18. Then we need x again. The opposite of multiplying is dividing. So to get rid of this 5, I need to divide. That will give me x greater or equal to 18 over 5. If you work this out, you will get x is greater or equal to 3.6. Okay, so now we have the solution set for x. We've been asked to indicate it on a number line. So all we have to do is just do a quick sketch. If you have one on your exam paper and your answer, you're writing on your exam paper, then you need to just follow that. Otherwise, you just need to draw a quick sketch. So we have x, and let's say that is 0 here, and then 1, 2, 3, 4, 5, roughly. I don't have, this is not negative or less, so I don't need to have a negative side. I don't need to show that, but you can do that if you like. So what you need to do is go to 3.6. So roughly it's just after the half between 3 and 4. Over here, we're going to mark it. And then we're going to write 3.6. Then we need to show a small circle, but we can either use a white circle or a black circle. So we're going to use a dark circle. Why? Because there's an equal sign, okay? And which side is greater than 3.6? So it's this side here to the right. And that's all you need to show. That is a solution for 3a. And now for 3b, we have a Venn diagram. You have set A and set B, and everything is called a universal set. We've been asked to write down the elements of a complement to start with. So what is a complement? It's said a complement it means anything that's not in A is a complement. So we need to use our curly brackets to mean set. So set A complement will have everything that's not in A. So I'm just going to write 1 is not in A, 2 is not in A, and 5 is not in A, 10 is not in A, 11 is not in A. So that is a complement. Now let's do a B complement. Again, similarly, anything that's not in B, we call it B complement. So B is everything on that side, everything in A, just A, not the intersection part. So 1 is a B complement. I can see 3 is a B complement, 4 is a B complement, and 7 is a B complement, 10 and 11. Okay, so that's B complement. Okay, and now for I then, I, we've been asked to write A union B. A union B. What does this mean? It means things that can be in A or B. So everything that's in A and B, basically. So let's just write them down. We have 2, we have 3, 4, 5, 6, 7, quite a few of them, 8 and 9. So that's A or B. Okay, now for the last part then, we're asked to find A complement union B complement. And all we have to do is just add these two up without repeating the elements, of course. So that's going to be 1, 2, 3, 4, 5, 7, 10, and 11. So that's part B done. And for part C then, we're asked to verify that number of elements in A union B is equal to number of A plus the number of B, take away number of elements in A intersection B. So if we start with the left hand side then, we have number of A union B, which is going to be equal to, so it's all elements in these two circles, 1, 2, 3, 4, 5, 6, 7, 8. And now let's check the right hand side then. What do we have? We have number of elements in A, so that's 1, 2, 3, 4, 5, 6. Number of elements in a B, so that's 1, 2, 3, 4, 5. And number of elements A intersection B, that's going to be equal to 3 elements. So now we can say number of element A plus number of element in B, take away number of element of A intersection B is equal to 6 plus 5, take away 3, which is equal to 8. So therefore, the left hand side is equal to the right hand side. So that is question 3 done. Thank you very much for watching, and remember to subscribe, and see you again. Bye bye.